This time, Resistor Networks Level 3. I'll just do a few problems at this level. There are quite a lot of different types of problems here. First one. Okay, E24 values, total resistance 198k. What's the biggest we can get there? Well, there is an E24 value which is 18. So 180k would be an E24 value. So if I take 198k and subtract 180k, that leaves me with 18k, which is another E24 value. So I could do this just with 180k and 18k here. And then I wouldn't need anything here at all. I could have that as 0. And that would do. And it does accept 0 values for the resistance, so that is a valid solution. Next. E24 values, this time 50, we've just done one of those. Oh, I could use this though to show you that if you get this wrong, for example, if I type this in as 57k, for example, that as 1k and this as 100 ohms, then that would total 58.1k, but 57k is not an E24 value, and it would tell you that. If I get the value wrong, if I put in, say, 2k here, for example, not 1k, then it would tell me that the value was wrong, and it would work out what it is and tell me that, just to give you a bit of extra help about where you've gone wrong. Right, different type, please. Expression for the total resistance of this network. Well, first of all, B and C are in series, so I could just add them up, B plus C, like that. They are then in parallel with D, so the combination of B and C and D in parallel would be 1 over B plus C plus 1 over D, and then that's the equivalent resistance of these three. That's in series with A, so I just add A. If I type a lowercase a, then it will give me this question mark sign, which doesn't automatically divide the score by 2, it just says something's wrong. In this case, lowercase letters not valid. It says capital A, it means capital A. It can be important to get that right. So that's fine. Another type, done one of those, here, right. Similar to what we've done before, but a slightly more complicated network. 87k18 minus this 82k, so I could work that out here. That would mean that 5180 must be the value of these three in parallel. And using the same technique that we talked about on level 2 with the formula used here, that would mean that the answer is 1 over the total of these three in parallel, which we've just worked out here, 5180, but we've assigned that to y, so I could just type y, minus 1 over 10k, minus 1 over 13k. And again, slight rounding error, because 87k18 is only accurate to 4 significant figures, but close enough to be marked correct. We could have guessed it was slightly wrong, because this quiz app always uses values of resistors that do actually exist. And 62.01k is not a resistor value that you can go and buy, but 62k is a very common value in the E24 series. This is just an extension of the thing we've done before. You could work out the formula using the same type of technique. The answer 18.31 minus 1 over, in this case 56, minus 1 over 180, minus 1 over 180 again, should give us the answer. Fine. And, a design one. This time, we have to make the total 651.1 ohms. out of these three resistors. How do you do it? Well, it's bigger than that one. There's quite a lot of possibilities here. Supposing we had 270 and then we put those two in parallel like that, what would that give us? Well, 270 plus 1K8 times 750 divided by 1K8 plus 750. 799.41. Nope, that's not right. Okay, next idea. Supposing we have the 750 and we put it in parallel with the series combination of those two. Then we would get 1 over 750 plus 1 over 270 plus 1K8, and it would be 1 divided by that lot. So that would give me 550. That's not right either. Okay, next idea. We could take these two and put them in parallel with the 1K8 like that. Now what would I get? 1 divided by 1 over 1K8 plus 1 over 270 plus 750. Ah! Got it! To 4 significant figures, that is 651.1. So the answer is, you connect the 1K8 up like that, you connect the 750 and the 270 in series, and put both of them in parallel with 1K8, and we got it. Sometimes these take a bit longer than others, but you will get there in the end. Okay, I think that's enough for level 3. Good luck.